we're gonna go over the last lesson before the quiz. So on Monday, you're gonna have a practice quiz, and then on Tuesday is your quiz, okay? So it'll be on everything we learned. Did we do it all this week? No. So what we learned last week, probably Thursday, Friday, and then, what we've learned this week, okay? On Tuesday too, did I tell you guys I'm not gonna be here? I have, I'll be in the building, but I'll be in a meeting, so, Mr. Horning is gonna be your sub on Tuesday, so, okay? Alright, so what we are going to do today is learn about tangents of a circle, okay? So if you think about things that we've learned so far, we've learned about radii, we've learned about diameters, we've learned about chords, okay? Today we're gonna learn about a special line, or it can be a segment, that touches a circle in one point. So a tangent intersects a circle in only one point, and the point that it intersects is called a point of tangency, okay? Yes.
Does this have anything to do with tangent speaking with trigonometry, or does it just have the same name?
Oh, I see what you're asking. Yeah, I never thought of that. No, it doesn't.
Okay.
No, it doesn't. I've never thought of that. No, it doesn't actually. So, okay, so AB is tangent to the circle at point A, and then it can be a segment, or it can be a ray, or it can be a line. So for something to be a tangent, don't think it has to have arrows on it, okay? Now, one of the things that they could ask you about is common tangents. They'd give you two circles and they'd ask you to draw all the tangents that you can. So you would draw any line that touched each circle in one point, okay? So that one, there's one, here's one where it touches both here. Could you do another one here? Yeah. Could you do more than one here? Because you probably see this one, right?
Yeah.
Oops. Are there any more? Top and bottom, yes. So you could draw one here. That would be tangent to both, and then you can draw one here. That's tangent to both. Okay? Could you draw two more here? Yes. So that's what this is about, is they're just gonna have you draw common tangents. How many do you think there would be here? Two, right? One on the top, one on the bottom. Okay, and I think, does it say just draw them? Okay. Here, how many do you think we could draw? Four, yes. We could draw one along the top. One along the bottom. And then you could draw one diagonally here. And then one diagonally here. All right? Then if I look at this one, how many do you think we could draw? Three. One right down here. Okay, and then one along the top. And one along the bottom.
You don't have to draw the points where it touches like the circle?
No, you don't have to. All right, how many for D?
Zero.
Zero, right? You couldn't do that. So we'll just say none. Okay? Alright, so now let's look. This isn't in your packet, but you have this in your cheat sheet. So you may want to have that out today because we're going to be doing some right triangle stuff again. Okay? So today what we're going to learn is we're going to learn some different theorems about a tangent. And the first one is if you have a circle and a tangent line, if you draw the radius of the circle perpendicular to that tangent line, then it would be tangent if it's perpendicular, okay? So if a line is truly a tangent, and you have that line and you draw from the circle to the point of tangency, that's going to form a right angle. So what they're going to do today is they're going to have these not be lines, they'll just be segments, and we'll be dealing with right triangle trigonometry. So they might say, this is 4, this is 5, what's that? Do you guys know that without looking? Please tell me you do.
8. No, sorry.
3, what, 5, 4, yes. 3, 4, 5. The other one I want you to know is 5, 12, 13. So 3, 4, 5, 5, 12, 13. All right, so if we look here, this is asking us to determine whether it's tangent to the circle and justify your answer. So what we're gonna do is just check, is 20 squared plus 21 squared equal to 28 squared? If it is, yes, it is a triangle, right triangle. If not, it's not. So I'm gonna just check, and by the way, your right angle, if you have a right angle, would be right there. So you're always gonna do the radius and that tangent segment squared equal to this. So I'm gonna go, is 20 squared plus 21 squared equal to 28 squared? Now this, you could punch in your calculator, but that's 400. This is 441. And 28 squared, I'm not sure of. That's 784. So that's not equal, correct? So they're not the same, so this is no, that's not tangent to the circle, okay? Then if we look at this one, where do you think the right angle would be here?
Like R.
R, yes. So here's my tangent segment, here's my radius. So if there is one, it's gonna be right there. So what we're gonna check here is the two smaller ones, 48 squared plus 14 squared equal to 50 squared. So we could do this on our calculator. We could check 48 squared plus 14 squared, and that's 2,500. 50 squared is also 2,500. So our answer would be yes, because both of these are 2,500. And it says justify your answer. This is the justifying, so, and then you can just say yes or no. Now here, which part would be my right angle again? What angle? Y. Okay, so if there is one, that's where it would be. So we're gonna say, is 4 squared plus 8 squared equal to the square root of 80 squared? Now 4 squared is 16, 8 squared is 64. What happens when you square a square root? They cancel. Is 16 plus 64 equal to 80? Yes. So that is tangent then. Okay? Now, here is another question that you will have today, and this part is a little bit confusing. So, first of all, there will be times that you're given a triangle and you're given a length, and you have to think about, is that length just this outside part of the circle, or is it the whole part? Okay? Now, one way to if you're ever in doubt on your quiz or test or something like that, ask me. But otherwise, if you look here, does it make sense for this whole segment to only be 9? No, because isn't that your hypotenuse? And for your hypotenuse, it has to be the biggest side, and this one's 15. Does anyone know what this distance would be? The radius, which is 8, right? Aren't these two radii of that circle, so they'd be the same? So this would be 8, okay? And then that makes this 17. You guys look at your Pythagorean theorem or triple sheet. Is it 8, 15, 17 a Pythagorean triple? And so then all you'd have to do is write yes. Don't worry about the justify, you guys. If you just have your yes or no there, that's fine. Okay? Then, let's look here. And again, like if you're ever in doubt, make sure you ask, especially on a test or a quiz. Does this one look like that 12 is meant for the whole thing? No. So this would be what? 6. Okay, so what would the whole thing be? 18. And wouldn't the 18 be the hypotenuse too, right? So we're gonna check, is 8 squared plus 6 squared equal to 18 squared? If you just write that and then put yes or no, I'm fine with that, okay? So 8 squared plus 6 squared is 100. 18 squared, did anyone put that? I think it's 324, is that right?
Yeah.
324, and that is not the same, so then we just say no. Okay? Now, this one is telling us their tangent, so we know that there's a right angle here, okay? And they're asking us to find x. Now, this first one, can I use the Pythagorean triple sheet for that? Is a 15, 20, and then something, is that a Pythagorean triple?
Yes.
If I look back here, 15, 20, 25 is 1, okay? So because of that, then I can come back, what sheet am I on? And I know that my x is just 25. If you didn't notice that, then you would do 15 squared plus 20 squared equals x squared and just solve that, okay? If I look at this one, do we think that 8 is that whole hypotenuse? No. So what would this be? 21. So that would make this 29. Now I don't believe, no. So if we go back here, down here, actually, no, right here, we're gonna have to use Pythagorean theorem. So I'm gonna do a squared plus b squared equals c squared. Do you guys all know that your right angle would be right here? So 29 would be your c. And then x squared plus 21 squared I could use for my a and b. So then I'd go x squared plus 441, I wanna say. Let's see.
Yes.
And then 29 squared is, whoops. Oof, that is not what I wanted. 29 squared is 841. you can subtract 441, and we would get that x squared equals 400, and then we would take the square root, and the square root of 400 is 20. Okay, now one thing I can tell you guys, if you ever get a whole number and your other two sides are whole numbers, that means that that's a Pythagorean triple. And if you wanted to add this one onto your sheet, a 20, 21, 29 is a Pythagorean triple. It's just, I didn't include all of them on that sheet, but that is one of them. And then if you doubled all of those, that one would work too. Okay, and that's probably as high as they would go on that. Now, this problem right here requires more work. So, first of all, do you all know our right angle is going to be right there? Okay. What do you think we can say for that side length? Yep.
The side length is 16.
We can't assume
Oh, I
that.
suppose.
Yeah, we just know that it's x, we don't know that it's 8 for sure. Okay, so do you guys get that I could write this as x plus 8? Everybody understand that? Okay, so here's what I'm gonna do. I'm gonna say, is x squared plus 12 squared equal to x plus 8 squared? Okay? Now, if I give every one of you this question right here, I would bet probably 80% of you would get it wrong. And I'm guessing this is what you guys would do. X squared plus 144. And then how would you write this? So x squared plus 64. Everybody agree? Most kids would do that. But actually that isn't the answer to that. When you have x plus 8 quantity squared, that is x plus 8 times x plus 8, and you have to use FOIL, okay? So you have to use FOIL there, and that's why this one is kind of a pain. So F is first, O is outside, I is inside, and L is last, okay? So if I rewrite this, this would be x squared plus 144 on that side. And then here I have to do FOIL. So first times first is x squared. O is outside, that's x times 8, which is 8x. I is inside, which is these, which is 8x. And L is last, which is these two multiplied, which is 64. What's different about this than what you guys said is we have that middle term, okay? So now if I redo this, I'm gonna say x squared plus 144 equals x squared plus, this is 16x plus 64, okay? What happens if you have an x squared on both sides? Do you guys know? They cancel out. If you tried to bring this over to that side and you subtracted it, what would happen is they would cancel on both sides, okay? So now it becomes easier because now I have 144 equals 16x plus 64, and then we're gonna subtract 64, and we get 16x equals 80 divided by 16, and x is 5. Okay? Then if we look at D, all right, anyone know what I could call this side? right here, x, right? If this is a radius and it's x, wouldn't that be x also? And then this would be what? X plus 2. I always put the x in front, like Lexi did. So now I'm checking a squared plus b squared, which is my x and my 4, is equal to the x plus 2 quantity squared, okay? So this is x squared plus 16 equals, and then here I have x plus 2 times x plus 2. And I have to do FOIL again, okay? So this is x squared plus 16. And when I go to do FOIL on that, remember f is first. So x times x is x squared. O is outside, that's x times 2, which is 2x. I is inside, which is 2x. And L is last, 2 times 2 is 4. Okay? Now, do my x squareds cancel again? Yes, and they should. If they don't, then you've done something wrong. Because then you'd have to factor, and you shouldn't have to do that on any of these. So x squareds are gone, so we have 16 equals 2x plus 2x is 4x plus 4. Then I'm going to subtract 4, and I get 4x equals 12, divide by 4, and x is 3. And that's what they want, is they just wanted what x was. Okay? Then let's go to the last page. We have one more rule about tangents, and this one I think is the easiest. So here's what this says. If you're at an outside point of a circle and you draw one tangent to one side of this circle, one tangent to the other side of this circle, and measure those, they are going to be equal. This is called an exterior point of the circle, and when you draw two segments, both of which are tangent to the circle, they're equal to one another. So if I come down here, all I have to do here is realize those two are going to be equal. I set them equal to each other and I solve for x. Okay, so I'm going to subtract x, and I get 2x minus 6 equals 10, and then I'm going to add 6, and I get that 2x is 16, and then I divide by 2, and x is 8. And again here, they just wanted us to find x, so that would be my answer. Then when I go to do the next one, it's the same thing. Those two are tangents from that same exterior point. So 4x plus 2 is just going to equal 2x plus 8. And then I'm going to bring my 2x over. And I get 2x plus 2 is 8. Subtract 2. And I get 2x is 6. Divide by 2, and x is 3. All right. Now the last kind of question like this looks like this, where you have several parts that are tangent to the circle from the same point. So notice I have two tangents from Q, I have two tangents from R, I have two tangents from P. And what this theorem told us is these two pieces are going to be equal. So if that's 4, this is 4. If this is 13, that's 13. And if that's 9, what would this be? 9, right? So the first question they ask us for is, what is x? So do you guys get that 2x would have to equal 9, right? For that down there to work. So x is just going to equal 4.5 or 4.5. So that's one answer. The second answer wants us to find the perimeter of the outside triangle, okay? So the perimeter would be 4 plus 4 plus 13 plus 13 plus 9 plus 9, which you would just add that together. Did anyone do that? 8 plus 18 is 26. Is it 52? 52 would be your answer. So one answer is to find x, one answer is to find the perimeter. Now if I look at this one, do you guys get if that's 5, this is 5, that's 13, this is 13, so that's our x. This is 5, this is 5, that's 13, that's 13. So our perimeter would be 5 plus 5 plus 5 plus 5, which is 20. And then 13 plus 13 plus 13 plus 13, which is 52. So it's going to be 72. Then if I look at this one, okay, is it easy to find x? Wouldn't 3x equal 18? So x is 6. Okay, so this is 18, that makes this 18, 12 and 12. Do you guys know how I'd find this distance? If the whole thing's 52 and that's 18, wouldn't I subtract and it would be what, 36?
34.
34, thank you. All right, then to find the perimeter around, 18 plus 18 is 36, 34 plus 34 is 68, 12 plus 12 is 24, 60 plus 68 is 128. Okay, this one's not bad at all. Wouldn't my x plus 2 have to equal 8? So x is 6. And then I'd have 8 and 8, 4 and 4, 9 and 9, 5 and 5. So that would be 5 and 5 is 10, 9 and 9 is 18, 4 and 4 is 8, and 8 and 8 is 16. So 26 plus 26 is 52. All right, so your assignment is out of the book. If it helps you, yes. Otherwise, I don't make you do that.
I'm saying there's not gonna be problems where you have to like draw all the tangents.
Yes, you may